Hello everyone and welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today as we continue our discussion of linear equations and linear functions. You'll notice today we are talking about parallel and perpendicular lines. I hesitate to tell you that in advance because a lot of this is going to be discovery and it seems kind of anticlimactic to go ahead and tell you what we're going to discover before we actually discover it. But that's okay. Let's go ahead and just dive right in today. You will notice that I have 4 linear functions written over here for you, as well as a coordinate plane. What I'd like for you to do is graph all 4 of those linear functions and then see if there's anything interesting or useful that you might happen to notice. If you have access to grid paper, I would suggest pausing the video, trying to graph these 4 on your own, and then rewatching to see if what you've done matches what I have done. You can also feel free to skim ahead if you're very good at graphing lines and you just want to see the final result. So what I'm going to do is I'm going to graph the first line here. You will notice that it is y equals 2x or 2x plus 0. Remember, the identity property of addition says I can stick in a plus 0 anytime I want because it doesn't do anything. Since these are all in slope-intercept form, when I graph this, I know that I'm going to cross the y-axis at the point 0, 0. Notice I've put my blue dot right there. And I notice that I'm going to grow at a rate of 2 every time. Or every time I rise 2, I'm going to run 1. That's up 2 over 1. And I'm going to continue that until I have enough dots to make the line. Now, ordinarily, if I were doing this by hand, I would make sure I put a bunch of dots down this way as well to make sure that my line did not accidentally stray off crooked when I was drawing it or using my ruler. But fortunately, I'm using a computer and all I have to do is cut and paste, so I didn't need to do all those dots, but you might want to do that. How about the second one? Y equals 2x plus 4. You'll notice that your y-intercept is a 4. So we start off at 4 on the y-axis, and once again we have a slope of 2. That means I'm going to start off at that y-intercept, and every time I go up 2, I'm going to go over 1 place. Up 2 over 1 place, and so on until I have enough to make my line. Once again, you're probably going to want to do down 2 backwards 1 a few times as well if you are doing this by hand. If I were to look at this third equation, I start off at -5. Using a slope of 2, I rise 2 and run 1. And then on the last equation, I'm going to start off at -8 on the y-axis. And once again, I'm going to rise 2 and run 1. Notice I start off at that -8. There's my cursor. At -8, up 2 over 1, up 2 over 1, up 2 over 1, and so on. At this point, I would recommend, if you have not already done so, that you would pause the video and think about what you might notice about those lines, both in graph form and in equation form. And I'm going to erase all this ink that I've scribbled all over the slide. Hopefully you've had a chance to do that. What'd you come up with? I'm hopeful that you noticed that the lines are parallel, and hopefully you noticed that the slopes are all the same. In fact, that is big idea number 1 for today's lesson. Lines that are parallel are going to have the exact same slope. Lines that are parallel are going to have the exact same slope. So let's talk about what that means. If I ever ask you, are these 2 lines parallel? What I'm really asking you is, do these 2 lines have the same slope? Notice you have the line 3x minus y equals -5. You have the line 5y minus 15x equals 10. If these lines have the same slope, then those lines will be parallel. If the lines are parallel, then they will have the same slope. Now, how am I going to find the slope of each of those lines? Hopefully you have a chance to sit and think about that by pausing the video. Probably your best bet is simply to change them into slope-intercept form, because when an equation is in slope-intercept form, it always tells you both the slope and the y-intercept. Remember, the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. So I want to rearrange this. Again, you might want to pause the video, try rearranging that on your own, and then fast forwarding to see if your rearrangement matches mine. Otherwise, we'll just work it out together. I'm going to start off by subtracting 3x's from both sides. Notice this is a negative y. A lot of people have a tendency to lose that minus sign. Be conscientious of that. The other thing you got to be careful about is this is a positive 3. A lot of people see that minus sign and so they try to add the 3, but the minus sign stays with the y. This is a positive 3. So we subtract 3 from both sides. Notice I could have written negative 5 minus 3x. I chose to put the negative 3x first because slope-intercept form has the x ahead of the y-intercept. I am not done yet because I still have this negative 1 in front of the y. So I'm going to divide both sides by negative 1, and I get y equals 3x plus 5. Notice here your slope is 3. If this second equation also has a slope of 3, then the lines will be parallel. If it does not have a slope of 3, then the lines are not parallel. Once again, I'm going to rearrange this. I would suggest pausing the video and doing that on your own before watching me do it, because I'm going to do it rather quickly. We add 15x's to both sides. Notice negative 15x plus 15x makes a 0. 10 plus 15x gives me 15x plus 10. Notice once again, I could have written it as 10 plus 15x, but addition is commutative. And in this case, we want the x to come first because of our pattern. I still have a times 5 over here. How do we get rid of a times 5? Well, the property of equality says I can divide both sides by 5, and these 5's become a 1. This is 1y equals 15 divided by 5 is 3, 10 divided by 5 is 2. Notice that you have a slope of 2. So are these lines parallel? Yes, these lines are parallel because they have the exact same slope. The idea? Again, I'm going to recommend that you pause the video, try this one on your own before watching me do it. That's certainly going to be more helpful for you than just listening to me say it and not knowing whether or not you are actually understanding. I'm going to take that first equation. I'm going to put it in slope-intercept form. Notice I have the y by itself over here without the x's or the numbers already, but I do still have this times 4. So I'm going to divide both sides by 4. Make sure you divide everything by 4. Negative 12 divided by 4 is negative 3. 16 divided by 4 is 4. Therefore, your slope is negative 3. Fortunately for us, the second equation is already in slope-intercept form. That's convenient. Notice that the slope is positive 3. The slopes are not the same. Therefore, these lines are not parallel. Again, these, notice I did end up with 3's and negative 3's for all my slopes. Your slopes can be anything at all, but they do have to match. Let's take this one step further and do something a little more challenging. I would like to write an equation of a line that passes through the point negative 1, 6, but is also parallel to y equals 2/3 x minus 5. If I were to plug a negative 1 into this equation, it would not give me a 6. I'm looking for a completely different equation that passes through this point, but has the exact same slope. That means if I were to take my point slope formula, I could plug in the slope, which is 2/3. That's the only thing this equation is good for. I take my example of an x, I take my example of a y, and I plug them all in. Notice the hard part for us is realizing that this serves no purpose except to give me the slope. Once I have the slope, I ignore this completely because I have a point, I have a slope, I use the point slope formula. And from here, it's really just a little calculation. Distribute the 2/3. Remember, minus negative 1 becomes plus positive 1, so 2/3 times 1 is 2/3. To get rid of the minus 6, I add 6 to both sides. And there's your solution. That's not too bad, is it? I don't think so. Again, the hardest part is simply the recognizing of what information you are given. Now that is the first of two things we need to learn today. The second thing we need to learn is illustrated by this set of lines. I would recommend, again, pausing the video, grabbing a piece of coordinate plane or coordinate paper or graph paper and graphing those on your own, seeing if you recognize something, and then watching the rest of the video. Because you can do that on your own, and I don't want to sit here in silence for several minutes, I'm going to keep going. If I want to graph y equals 2x minus 3, I notice that my y-intercept is -3, so I graph that. I notice that I have a slope of 2. That's up 2 over 1, giving me this line. Again, make as many points as necessary to make sure that your graph does not get crooked on accident. When I go to graph the second equation, it has a slope of -1/2. It has a y-intercept of 7, so I graph that. Y-intercept -7. This says go down 1 every time we go over 2. That's down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and so on and so forth. Do you notice anything interesting about these equations or these graphs? Well, hopefully you figured it out, and if not, the title of the slideshow should have given it away. These lines are perpendicular. What's more challenging is to figure out why they are perpendicular, and hopefully you'll pause the video and think about that before you listen to me explain it. I'm going to go ahead and tell you that these lines are perpendicular because of how these two lines are slanted. Notice that they have to slant in such a way that they cross at a right angle. That's the definition of perpendicular. So it's actually the slantedness of the lines that cause the perpendicular to occur. Since I'm concerned with the slantedness of the lines, I'm going to look over here at the slopes. The blue line had a slope of 2. The red line had a slope of -1/2. Do you notice anything interesting about those two slopes? Did you notice that those are opposite reciprocals? 2 and 1/2 are reciprocals of one another. 2 over 1, if I flip it upside down, gives me 1 over 2. But notice that one is positive and the other is negative. That's big idea number 2 for today. Lines that are perpendicular have slopes that are opposite reciprocals. So that if I were to give you a line that has a slope of 2/3, and a line that has a slope of -3/2. Hopefully we can look at those and realize 2/3 and 3/2 are reciprocals, and we should notice that one is positive and the other is negative. Given what we learned on the last slide, I would expect these two lines to be perpendicular. So let's graph them. The blue line says I'm going to cross the y-axis at -4, so I put a dot there. The slope says go up 2 every time I go over 3, up 2, over 3, and I'm just going to keep repeating that as many times as it takes to get a nice straight line. When I go to graph the red line, it's going to cross the y-axis at 9, and it's going to go down 3 every time it goes to the right 2. Notice down 3, right 2, down 3, right 2, down 3, right 2, down 3, right 2, and so on. And notice, of course, that these are, in fact, perpendicular like we would expect. Lines that are perpendicular have slopes that are opposite reciprocals of one another. So, if I ever ask you, are these lines perpendicular? What I'm really asking you is, when I compare their slopes, are their slopes opposite reciprocals? And we're going to do this exactly the same way we did it with our parallel line problems. Meaning, I'm going to put both of these equations into slope-intercept form. Once they're in slope-intercept form, it's very easy for me to compare the slopes. So, again, I would recommend pausing the video, trying this on your own. I'm going to keep right on going. If I want it in slope-intercept form, I've got to move that x. Notice that a negative x and a positive x make a 0. That leaves me with 2y equals x plus 2. I still have to get rid of that times 2, so I divide both sides by 2. Be sure to divide everything by 2. This is a 1x, so now it's 1/2. 2 divided by 2 makes 1. Notice that your slope is 1/2. Your second equation, we're going to move the 4 to the other side, and then we're going to divide both sides by -2. Notice we get 1 divided by -2 is -1/2. -4 divided by -2 gives us a +2, and -2 divided by -2 gives you 1. This is in slope-intercept form, but I'm going to use the symmetric property, and I'm going to write it in the way you are more familiar with. That's y equals -1/2 x plus 2. Some people it bothers if the equals y is on the right. The symmetric property says if two things are equal, we can switch which side of the equal sign they are on. The important thing for us is the slope is -1/2. If this has a slope of 1/2 and this has a slope of -1/2, are they perpendicular? No. The rule is they must be opposite reciprocals. This is an opposite, but it is not the reciprocal. If they were perpendicular, this would have had a slope of -2. However, it doesn't. So I've cleared off all the ink writing. I'd like you to go ahead and try this last one here on your own. Make sure that you pause the video and try that before watching me do it. That is going to be much more helpful to you, because then you can compare it to my answer and you can see what errors you are tending to make. You can also spot it if I make an error. Notice I can divide both sides of this by a 4. Give me y equals 3/4 x plus, this should be a 3. Got a nasty little typo there. I'll have to go back and fix that later on. Either way, it does not change the slope. The slope is 3/4. And then over here for the second equation, I'm going to subtract 4x from both sides. When I do that, the 4x is over here. I'm going to leave the y where it's at. I want to move this -18. And when I do that, I have 3y equals -4x plus 18. That's this right here. I still need to get rid of that times 3, so I'm going to divide both sides by 3. Make sure when you divide both sides by 3 that you divide the -4 and the 18 by 3. That gives you -4/3 x plus 6. Here, your slope is -4/3. 3/4, -4/3, are these perpendicular? And they are. Remember, if things are reciprocals of one another, like 3/4 and 4/3, when you multiply them together, you should get something that is equal to a 1, like the 12/12. That's how I can see these. I've got 3/4 times 4/3 would be 12/12. One is positive and the other is negative. Let's do one last example. Write an equation of a line that contains the point 1, 2 that is perpendicular to y equals -3x minus 1. Here's what I know. I know my line needs to contain this point. And I know I need it to be perpendicular to this line. If it's perpendicular to this line, I need to use the reciprocal of -3. Or if you prefer to think of it as -3/1, you can do that. What's the reciprocal of -3/1? Well, the reciprocal of 3/1 is 1/3. I use the opposite, which makes it positive. Remember, 1/3 times 3 would equal a 1. I do have an x and a y here, which means I have enough information to use my point-slope formula. Again, we always rewrite the formula because it does 3 things. Number 1, it helps us memorize it. Number 2, it keeps us from making careless mistakes. And number 3, it helps other people understand what we are doing when they read our work. So I plug in those values. The 2 goes in for y, the 1 goes in for x, and the 1/3 goes in for m. And then I just use my distributive property. And then I use the property of equality, and I come up with my solution. Notice, y equals 1/3 x plus 1 2/3. It does have a slope that is opposite reciprocal, so it will be perpendicular. If I were to plug in a 1, 1/3 times 1 is 1/3. 1/3 plus 1 2/3 equals the 2. So this point does, in fact, work. Hopefully that's been useful for you. As I mentioned, most of the difficulty with this lesson is more in the realizing what you do need to use and don't need to use. I have a lot of students that get themselves in trouble because they use this equation right here for too much. Remember, the only job of that equation is to help us in determining the slope. Other than that, we have to use the point slope formula. Hopefully, like I said, this has been good for you. If you have enjoyed this or if it has helped you, please give us a big old thumbs up so that we know that it has been useful. And then make sure you ring that bell to turn on your notifications so that anytime we put something new out at Nunley Math, you can see it. Thank you once again. Take care of yourselves. Bye-bye.